Okay, so good afternoon, everybody. I'm going to take you through Protolabs and how we help engineers accelerate innovation through digital manufacturing. My name's Steve Lewis-Brammer, and I'm the Northern Europe Region Sales Director for Protolabs. I've been here for around 2 years, but I've been working with the engineering and manufacturing industry for around about 30 years, dare I say, so showing my age as we talk our way through. But what I'm going to do this afternoon is just explain to you who we are as a company and how we may be able to help you in terms of your new project development. And in particular, how we can help you save time, save money, and get products to market faster, which is what it's all about nowadays. So first point we're going to look at is who is Protolabs, because we're not necessarily a name that you will know directly, not necessarily a name that unless you're operating in the new product development market and you're receiving information from us on a regular basis, whether you've come across us as a company, but the chances are you've probably seen, used, or been involved in working with a product that we've been involved in developing over the last 23 years. Because at Protolabs, we invented digital manufacturing. It all started back in 1999. Our founder, a man called Larry Lucas, was looking at sourcing injection molding parts, and he was frustrated just how long it took to get a quote for parts, then receive the parts. And when he worked alongside what he had to do in terms of iterating those parts and getting them through to the final stages before they could release it into production, Larry was convinced there had to be a better way of getting this done. So he started to work on what became eventually the backbone of the Protolabs system, which is a software that I'll take you through and explain how it works. But it's worked so successfully that nowadays we tend to serve over 60 countries around the world from 12 global manufacturing facilities. We have over 1 million square feet of manufacturing space, and that's still increasing. We've opened recently new facilities in both Europe and the US, and we serve over 55,000 unique product developers around the world. In terms of the number of parts that we produce on a monthly basis, if you look down at the bottom of the screen, you'll see that we produce 130,000 plus 3D printed parts a month and 70,000 plus CNC parts a month. And if you're in the mass manufacturing industry, you may not be overly impressed by those figures. If, however, I tell you that, for example, if we look at CNC manufacturing, that typically the numbers of parts that we tend to produce per batch average around about 10, you'll start to see it differently and realize that, geez, 10 parts a batch and 70,000 parts a month means what a heck of a lot of setups. And that's effectively what the Protolabs model is about. It's about doing things extremely quickly and helping get new ideas off the ground extremely fast. If you're looking for higher volume manufacturing, whilst we don't get into the mass manufacturing sphere as such, we do have an on-demand manufacturing service which deals with what we term as low to mid-volume manufacturing requirements. And we support our customers with that in the injection molding line service in particular. And you'll see there that we're producing something like now 4.4 million parts a month. And again, that continues to increase over time. It's a service we've introduced in more recent years. So it's a growth industry for us, and people are looking more and more for that. And there's a reason for that, which I'll come to on part way through the presentation. So it gives you a bit of an idea of who we are as a company and the sort of size of the organization. But to show you what it looks like from our customer's perspective, rather than me explain it, I'll just play you a little video that gives you an idea how our system works for our customers. Here we go.
We've reinvented our digital manufacturing platform to help you iterate designs and launch custom components faster. Improved user experience, streamlined quoting, optimized design analysis, more parts, more projects, more efficient workflow. Go from prototype to production faster with Protolabs.
There you go. They say that a picture tells the story of 1,000 words, so better to watch the video than it is to hear me explain it. But you see, from a customer's point of view, that the ecom platform is extremely simple to use. You literally would take a CAD design, load it up into the software, and the software will then literally take the design, it will understand it, it will provide a quote with design for manufacturing feedback, a point I'll come and expand on in just a few seconds. And then it allows you to see if there's any issues with the part in terms of making it manufacturable. Gets it through to the order stage, and then once you click the order through, the software that Larry and the team here at Protolabs have developed then takes it through into the manufacturing side. We link to the hardware, the actual manufacturing machines themselves. We produce the parts, get it through to quality inspection, through into packing and shipping, and the part comes through to you. And this digital manufacturing infinity loop that you see in front of you explains that whenever you have an idea, literally we can support you all the way through the process. And whether it's then reiterating the part and moving it on, or whether it's coming up with the next project or the next concept, we're there to support you and keep it working through. And it's the software that allows all of that to work at unprecedented speeds as such. To relate that then in terms of what that means to design engineers as such, and why so many design engineers use it, I'm going to take a look at how traditional manufacturing and prototyping compares to what we do here at Protolabs. So typically a manufacturing development, when we look at a new product, it goes through 3 stages. It goes through what's called the rapid prototyping stage, it goes through the engineering build, and then it gets into verification and validation stage. And if we take a look at how that looks from a traditional manufacturing background, what tends to happen is in the rapid prototyping stage, there are a couple of phases that exist. There's the initial prototypes and the iterations. Nowadays, they're done in either CNC and or 3D printing. And in terms of the time frame that can take, it's not uncommon for the initial prototypes between quoting and getting hold of the initial parts for that to take a month, and then another 2 or 3 months for the iterations to be worked on. Again, the whole process of getting new quotes, getting the thing pulled through, and actually physically getting the parts and getting to a stage where you're happy with it. Once people have gone through that phase and they're happy to progress, it moves into the engineering build phase of the project. And again, there could be a couple of stages of that. We're showing 2 on this illustration that you see in front of you. And if it's now going to be a plastic part, more often than not, it moves into injection molding. In injection molding, traditionally, you'd use a steel tool. Now, because of the complexity of manufacturing those steel tools, and nowadays where they tend to be sourced from around the world and the time it takes to get them from those locations to wherever you are as a customer, again, it's not uncommon for that to take a number of months on the way through. And we're showing on this diagram here that could take 2 months for phase 1, 2 months for phase 2. And then you finally move into the verification and validation stage. And at this stage now, again, you'd be looking at steel tool if it's going to be a plastic part that's mass manufactured. Time frame for that, again, could be a couple of months for each of those stages for the various testing and certification until it's finally approved, goes through to launch. And the whole process from beginning to end could take 12 months or more. And that's obviously a considerable amount of time. And what we're all finding nowadays is the world's moving faster. People are more impatient. They want things to come through, and that includes all of our customers. So at Protolabs, we have a different solution to that. And what tends to separate us is the software that runs behind and the digital thread that goes through from actually receiving the CAD drawing and reading and understanding it, giving the feedback, and then literally getting through to the stage where we can manufacture the parts based on the information that we've generated and agreed with you as a customer. And literally what took months before, so if we look at the rapid prototyping, now takes weeks. Just as in the traditional model, we also use CNC manufacturing and or 3D printing. But as I mentioned, we're down into weeks instead of months. And it's the same thing with the engineering build phase of the project. Again, whether it's 1 or 2 or 3 phases or whatever it is, because of the speed that we can do it in. And in our case, we actually make the injection molding tools in aluminium, which are good to produce a yield of up to 2,000 parts, depending on the complexity of the part itself. Then we can do that much faster. Again, should you require to produce more parts than that, we have options available in terms of our on-demand manufacturing tooling, but you're talking weeks to get the tools made and produced and the initial samples in your hand. Once we come out of that, effectively, you move away from us, you move into more traditional manufacturing methods. Time frame on those stays the same, but because of that initial block of time that we've managed to save and help and reduce the number of iterations, reduce costs and various headaches that go with it, you're now looking at a total time to market of around about 6 months. So half the time it would have taken using the traditional method. And again, our customers are finding that gives them a competitive edge. It allows them to get to market faster and start generating revenue from product ideas much faster than they would have done previously. One of the things I mentioned earlier that our customers love about us is what's called design for manufacturability feedback. And what happens in our software is when we return a quote through to a customer and you've uploaded it, we can highlight any issues with the part that possibly may cause you a headache. There may be things that may need previously reiterating, which would be more cost, more time, more delays. But here we're telling you up front various areas. So you can see things, for example, such as on this particular part, thick parts, which are highlighted there in the blue. So there could be some sinkage on the part. Thin parts, as you see on the yellow. So there could be issues about the actual structural capability. Where the ejector molding pins are going in the part. So again, you may have issues where those pins are going to be located. You may want to change that. You may want to discuss that on the way through. And then similarly, we'll show you where the ejection gate or injection gate is on the part where we're going to put the material in, again, for aesthetics and for functional reasons. So our customers who tend to use us on a regular basis find this is really useful and actually use it as part of their design process to eliminate the number of steps, to eliminate the time it takes to come up with a final design and work it through. Why is that important? Well, it's important if we look at it because in manufacturing nowadays, things are changing on a regular basis. Manufacturing is evolving. And if we look at a quote by Peter Drucker, who is the famous management consultant, he said that the pace of business nowadays, the only constant he said that exists in business is that it's changing. Business does change. Nothing remains the same. And the pace of that change, he said, is only getting faster and faster. And we've found exactly that. And in particular, over the last 2 years since the COVID pandemic hit, we found that a number of issues have now come to the fore more than they were doing before for our customers, and they may well be the same for you. And the three things that we're finding more than anything else is there's been a shift in demand in the marketplace. Our customers are finding that their customers' needs have changed, and they're changing quickly, and they're changing often. They don't necessarily stay the same for a long period of time. They find that there's a change in the supply chain's ability to be able to serve them and look after them. And that there's various issues, not just with COVID itself, but the knock-on impact that's come as a result of that. And so we're finding that customers are looking really for value-based supply chain strategies for people who can support them, not just with making the parts, but looking at a broader picture about where the part fits in, about things that go around it, and so on. And at Protolabs, we're able to adapt to that because of the nature of the digital system that we have. We found that customers are looking for more agility and more flexibility. So they're looking for that in terms of not only a manufacturer that can respond quickly, but can respond differently as and when required. So if they have a need to change a part or come up with a new concept, there isn't all of this time that you just saw on the diagram on the way through, but within 15 days, within 7 days, within 5 days, they're able to respond to something, make the changes as needed, and be able to get a product through its development cycle and make it readily available for their customers. So we're finding that is a big thing that is happening in the market at the moment, and it's likely that that change will remain. It will remain a constant, and again, just the pace of it will just provide more and more pressure on people. So we can help with that. And again, the third change we're finding as a result of the pandemic is the way people are working now is different. Employee safety remains the number one concern of businesses. And again, for lots of businesses, they've introduced working from home policies. So you now have teams of engineers and buyers and product developers who may be working in different locations or all of them working from home. But they're looking for the ability to be able still to collaborate on projects as if they are working together in an office. And our platform gives them the ability to be able to do that. And not only that, within their own company, but if they've got a supply chain that's involved in it. So, for example, an automotive company could be buying an assembly from a tiered supplier. They can actually share the rights with that tiered supplier, that once they've gone through and designed it, the tiered supplier has the ability to be able to get those parts and work it through from us. So the Protolabs platform allows people to be able to deal with those three needs that have come to the surface, if you like, come to the forefront over this last few years. What does that mean then in terms of manufacturing processes and how we support it? So we've talked about the time that we can actually produce parts and get them through to customers. But if we look at that by service line itself, we take a look at each of the service lines. Initially, we look at injection molding, which is where we started as a company. I mentioned about Larry Lucas was frustrated with this. As a result of the work that the team did and the platform that we've got now and the software that we run behind it, we have the ability to effectively deliver injection molded parts from concept, from idea, through to real parts within 15 days. And that literally is receiving the CAD drawing, agreeing on the quote, and once that order is put through, within 15 days, we can have manufactured the mold, produced the first off batch of samples, and had those samples in a customer's hands to be able to approve them or do whatever they need to do with them on the way through. And it doesn't matter whether that's 25 parts, whether that's 10,000 or more parts. If they're looking for an on-demand manufacturing mold, it is possible. And that applies not only to plastic injection molding, it applies to liquid silicone rubber molding, it applies to overmolding, and it equally applies to insert molding. So we've got quite a range of capabilities that exist on there. And we've got different mold sizes, different machines that we can produce a range of part sizes depending on whatever you need. Moving through into CNC machining, whether it's plastic or metal parts that you're looking for. Again, we have a range of lathes and a range of milling machines that allow us to be able to turn CNC machine parts literally from the point of order to being manufactured and shipped within 1 to 3 days. And again, we have the ability to put helicoil threads in there to insert them. It's 3 and 5 axis milling. And equally, we've got turning capabilities, I mentioned, with lathes to be able to design features and machine features on parts ready for them to come through and be at the stage you want them to. If those parts are being machined in things like aluminium, then equally we've got secondary services that I'll come to in a short while, that if you're looking for more than just the part being made, there are things we can do to the part, again, to reduce your dependency on a number of suppliers and to be able to get it all from one source on the way through. Just as we do in the CNC, we also offer the ability to be able to produce parts in metal and plastic in terms of 3D printing. And we are what's known as technology agnostic at Protolabs, which means effectively we don't favor a particular method of printing parts. So our service includes direct metal laser sintering for metal parts. It includes stereolithography, selective laser sintering, multi-jet fusion, and also polyjet. And the idea is that we can best support your need in terms of offering the right service to match that need on the way through. And whether it's 1 parts, whether it's 50 parts, again, you can have parts shipped within literally between 1 and 7 days as a rule. And again, if you're looking for parts that are just for fit and functionality testing or fit and form testing, if you're looking for parts that have every single feature on them, the chances are we've got a solution that will fit and will be able to be used for you. And again, I'll come to some examples of this that you can see later, the sort of thing that we do and how we put things through. So I mentioned earlier when we came to the CNC that We also now have been requested in recent times to look more about secondary services, things that supplement the actual manufacturing of the components themselves. So we now offer things such as pad printing, we offer assembly, we offer testing, including things like PPAPs and FAIR documents. We equally are involved in going through and assembling the components through to a sub-assembly stage for some of our customers. So anything you're looking for in terms of that, you'll find details on our website. And equally, if there's something you don't see that you're interested in seeing, could we possibly support you on that need, by all means talk to us and we'll have a look at what is possible. We appreciate that. If we can save you some time and effort and money on the way of going through that, we'll do what we can do to support you and help you through the product development phases. So what does that look like then in terms of when it all comes together, when it works? I mentioned to you earlier, the chances are you've probably seen or come into contact with or even used a product that we've been involved in developing over years. So just to show you what some of those things may include, there's such a diverse range of parts and industries that we work with. But just to give you some ideas of what that looks like, it could be anything as simple as a product appeal in terms of the vial of a vodka bottle that's put out there, so something different aesthetically than you would typically see on a bottle of vodka that exists out there. The other end of the spectrum, we may be making parts that go into help literally life-saving situations, and we make parts for drones to save lives at sea. We manufacture complex parts for safety and endurance testing. So again, it isn't necessarily that they're just used for a cosmetic or a new application device. They could be used for something that's doing some very complicated work on the way through. Equally, at the other end of the scale, we could be making 3D printed masks that were promoting the Black Panther movie when that came out, and we did that in conjunction with Pepsi. So completely different applications, completely different needs, completely different markets for those sorts of things. It's interesting to be in something that is so different. And as an example of that, again, we worked with a designer by the name of Zach Posen to design a series of 3D printed gowns, which was testing the industry and applying technology and methodology that had never been used before. And the example that you see on your screens to the left-hand side is a dress that was printed to replicate rose petal designs, and it was worn by an actress at the Met Gala dinner, and just showed what is possible moving outside of traditional manufacturing methodologies within the fashion industry. To the right of that, you then have products which improves people's quality of life with a device here that is aimed at reducing tinnitus. It's a device that's 3D printed, but if you take a closer look to it, you'll see some black material that's over molded on it, and that's liquid silicon rubber. And what we do here is we actually produce the liquid silicon rubber parts, we produce the 3D printed parts, and we assemble all of that together as a unit and supply it to our customer as a complete assembly. So again, I mentioned earlier about supplementary services. Please talk to us about anything you may be looking for, and we'll see if we can help and make things happen on the way through. And then finally, it could be, if you're into the adrenaline rush of BattleBots, you may well have seen the BattleBot duck. Well, we were involved in making parts for duck and causing its destruction to every adversary that it faced in the BattleBots arena. And on the other hand, to the right-hand side, you'll see what is really a conventional product that many of us have used for a number of years around the world, a traditional stovetop espresso machine. But this particular version incorporates a different idea, and somebody's been innovative and decided that what they're going to do is bring in the concept of a jet engineered capability to actually boil the coffee and produce the espresso through it. And again, we were involved in making the parts for that. So literally, it's a diverse range of options, whatever it is you're working on, if it's plastic or metal parts, and it can be 3D printed, if it can be CNC machined or injection molded, the chances are that we can help. I appreciate in the time I've been talking to you, it's quite a lot of information to take on board. It's certainly not all of the information as you can well imagine. And so there are additional resources that are available. We appreciate sometimes for designers, and especially new designers who are coming into industry, where do you get information? Where do you get the resources? Who can you rely on, and so on? And one of the things we pride ourselves at Protolabs is being able to offer information for people. So we've got a vast resource of educational material, whether it be white papers that are based on specific industries, such as the aviation report that you see on the screen there, or whether it's for automotive or electric vehicles. We have the design cube that you'll see in the center, which shows when it comes to designing for injection molding, how parts can be manufactured and some of the pitfalls to avoid, such as making areas of components too thick, how to look at manufacturing a boss on a component and so on, so you can reduce the amount of material use so the part is structurally strong and so on. So there's a range of materials that come in there. We've recently found, for example, that a lot of designers now are coming into industry and they're capable of designing for 3D printing, but it doesn't necessarily relate and transfer across into designing for injection molding or designing for CNC. Equally, we have other industries, other customers who are at the opposite side of that spectrum. They're used to designing for more traditional subtracted methodologies. They're not necessarily schooled or knowledgeable or experienced in designing for 3D printing, where you might want to take advantage of geometries that can't be produced the other ways, or you might want to lightweight components that traditionally would have used heavy blocks of material. So there are things on there that can be done, and there's plenty of information on the resource hub that you'll find on our website. And if you take a look at it, it's all available on the website of the company, which is protolabs.co.uk. And when you go in there, you'll find all sorts of information. If, as I mentioned to you earlier, you're old school like me and you just prefer speaking to somebody, or you want to send an email and initiate a conversation or a meeting or a webinar such as this, we've got account managers and application engineers who'll gladly give you their time, gladly offer whatever support we can and help you see how we can bring your products, your projects, if you like, into reality. So you get real parts from your idea real fast. That's it for Protolabs. Thank you for listening.